Good morning, students. Today let us learn about the chemical equations. So the topic is chemical equations. A chemical equation is a short hand representation of a chemical reaction with the help of chemical symbols and formulae. In the previous classes we told that how to write the how to write the compound names, how to mark the anions and the cations, and you have learned already about how are the ions are formed and how to find out the monovalent and divalent and trivalent everything. So this class we are going to learn about the chemical equation. So to represent a chemical reaction we have to take the name of the elements in the short form in the way how we are doing, and after that accordingly we have to show it in the reaction form so that it will be easy for everybody to understand that reaction. So a chemical reaction or a chemical equation is a chemical equation is a shorthand representation of a chemical reaction with the help of chemical symbols and formula. With the chemical symbols and formula we can understand the chemical equation. Every chemical equation has two components, reactants and the products. One side it will be reactants, the other side after the arrow mark what it comes it will be as the products. Reactants are the substances that take part in a chemical reaction, and the products are the substances that are formed in a chemical reaction. So after the chemical reaction takes place, what is the product form, what is the substance form, that will be the product, and what all the elements or what all the substances participate in the chemical reaction, that will be the reactants. So now steps in writing the skeleton equation. How to write a chemical equation. That the first step, write the symbols and formula of each of the reactants on the left hand side. Always we have to write on the left hand side all the reactants and join them by plus. The next step is follow them by an arrow mark which is interpreted as given or forms. After the reactants on the left hand side, it will be followed by the arrow mark. Then the next step, on the right hand side of the arrow mark, the symbols and the formula for each of the products. So after the substance has been reactants as there, after that the products will be written after the in the right hand side. If the product is a gas, it should be represented by upward arrow. If it is a gas, it should be in the upward arrow, and if it is the precipitate, it should be represented by downward arrow. If it is in the upper form, it should be the in the gaseous form. If it is in the lower arrow mark, it will be in the precipitate form. Example, see how they are written: Mg plus H2SO4, that means magnesium and sulfuric acid are the reactants, and the product formed after the arrow mark what is written is the product. It is magnesium sulfate and hydrogen. Since the upper arrow mark, that means hydrogen is the gaseous form. So what is the how it is the reactants? So magnesium plus sulfuric acid gives magnesium sulfate plus hydrogen, that is hydrogen is in the upper arrow mark. Okay, then balancing a chemical equation. How to balance a chemical equation? According to a law of conservation of mass. So as per the law of conservation of mass, the total mass of all the atoms forming the reactant should be equal to that of the atoms forming the products. So how much reactants have been participated in the reaction, that much amount of mass should be there on the in the product also. The mass should be equal. The reactants mass and the products mass should be always be equal. For that only the chemical reaction or the chemical equation is balanced. This law will hold good only when the number of atoms of all types of elements on both the sides are equal. On both the sides it is equal only, that what will happen, the equal mass is stabilized. Then a balanced chemical equation is one in which the total number of atoms of any element on the reactant side is equal to the total number of atoms of that element on the product side. The total number of atoms on the reactant side is equal to the total number of atoms in the product side. Okay, that is how For that purpose only we have to balance the equation. Then for that, what are the steps for balancing the equation? There are many methods of balancing a chemical equation. Trial and error method, fractional method, and odd number even number method are some of them. So different types of how to balance the equation is there. Trial method, then fractional method, odd number even number method. Initially, the number of times an element occurs on both the sides of the skeleton equation should be counted. How many numbers of number of times an element is occurs? It should be equally. Should be calculated first, both in the reactant side and the product side. An element which occurs least number of times in reactant and the product side must be balanced first. First, we have to balance the product side. That means after the arrow mark, what it is there, that should be balanced first. Then elements occurring 2 times, elements occurring 3 times, and so on in an increasing order must be balanced. 2 times, 3 times, in that order only it should be balanced. First the product side should be balanced, then only the reactant side it should be balanced. When 2 or more elements occur same number of times, the metallic element is balanced first in preference to non-metallic elements. First the metal should be balanced, then the non-metal should be balanced. If more than one metal or non-metal is present, then a metal or non-metal with a higher atomic mass is balanced first. If metals and non-metals are first, with a higher atomic mass should be balanced first. The number of molecules of reactants and products are written as coefficient. So then the number of reactants and the products products are written as coefficient. The formula should not be changed to make the elements equal. The formula also should not be changed to make the elements equal. The formula also should not be made. Then fractional method of balancing must be employed only for molecules of an element, oxygen, hydrogen and phosphorus, not for compound H2O or NH3. We should for single only they have to be get balanced. We should not for balance it for compounds. Okay, that is a fractional method. Now let us balance the equation for the reaction of hydrogen and oxygen which gives water. So what is water, how it is written, the equation H2O. So first we will try with how the water equation is balanced. Step 1, write the word equation hydrogen plus oxygen gives water. Write the skeleton equation H2 plus O2 gives H2O. Then select the element which is to be balanced first. Based on the number of times an element occurs on both the sides of the skeleton. On both the sides, how many times each element occurs, according to that we have to balance it. See number of times particular hydrogen, H2 it is given. So 2 times hydrogen is there. And O, that means only 1 time the oxygen is there. So it is hydrogen 2 times and oxygen 1 time. The next one, in the above case both the elements occur 1 time each. Here preference must be given to the oxygen because it has a higher atomic mass. So first preference always to the atomic mass, which element is to that, then metals, then if metallic and non-metallic you have to see again the atomic mass. So in this order to balance the oxygen, put 2 before H2O on the right hand side. So what will happen? It will become 2H2O. Okay. So to balance hydrogen, put 2 near the hydrogen on the left hand side. So what will become 2H2O. So hydrogen here it will become 4 and oxygen it will become 2. Then information now on both the sides number of hydrogen atoms in 4 and oxygen atoms is 2. Thus the chemical equation is balanced. So the chemical equation is balanced. Okay. Now information conveyed by a balanced chemical equation. A balanced chemical equation give both qualitative and quantitative information. Both the qualitative and quantitative information will be given by a balanced equation. Okay. It gives a qualitative information. That means a balanced equation always gives both qualitative and quantitative equation. So in other words, some of the things will not be conveyed in a chemical equation. What are they? Physical state of the reactants and the products. What is the physical state, whether it is in the solid state or whether it is a liquid state, that it will not be mentioned in a chemical equation. heat changes liberated or heated or absorbed accompanying the chemical reaction. These also will not be conveyed in the chemical equation. Then conditions such as temperature, pressure, catalyst, etc., under which the reaction takes place, under which all conditions this reactions takes place, that also will not be conveyed in a chemical equation. Concentration, dilute or concentrator of the reactants and the products, that will be mentioned. Then speed of the reaction, what will be the speed of the reaction, that also will be not conveyed in the reactants. So these are the things which are not conveyed in a reactants. Okay, so these are the things which will not be conveyed in a reaction. So what are the things this can be conveyed? It gives a qualitative information such as the names, symbols and formulas of the reactant molecules taking part in the reaction. So what all will be found? Names will be found, symbols and formulas and reactant molecules will be found. We can also get the quantitative information like the number of molecules, atoms of the reactants and products that are taking place. How much amount of the reactants and the products are taking part also in the reaction, that also will be mentioned in the chemical equation. So what are not mentioned and what are not mentioned in a chemical equation, I think you are clear about that. So next comes the law of conservation. Law of conservation or law of chemical combination. In this, the different laws of conservations are there. Law of conservation of mass, law of constant proportion, law of multiple proportion, and Lusak's law of gaseous volumes. These are the different law of chemical combination. In this, first we are going to learn about the law of conservation. In the law of conservation, it states that during any chemical change, the total mass of products is equal to the total mass of reactants. How much the reactants, how much mass, how much weight of reactants participate in a reaction, that much amount of product also will be formed. That is chemical law of conservation of mass. In other words, the law of conservation of mass means the mass can neither be created nor be destroyed during any chemical reaction. The number of how many mass can be, how much the mass has been participated in the reactors, that much mass will not be destroyed also in a chemical reaction. This law is known as law of indestructibility of mass. So what is law of indestructibility of mass? The law of conservation of mass means that the mass can neither be created nor destroyed in a chemical reaction. You have studied in law of conservation of energy in lower classes. Energy can neither be created nor destroyed. The same thing, the same here, in place of energy you can make use of the word mass. Okay. Then here they have shown one activity that you can read by yourself. It's a very simple activity. Then or prepare 5% of barium in a prepare a 5% of barium and sodium sulfate solution separately. We have to prepare a barium and sodium sulfate solution separately. Then take some solution of the sodium sulfate in a conical flask and some solution of barium chloride in a test tube. So conical flask, what you will take? You will take barium chloride, and the other one, what you will take? The sodium sulfate. So sodium sulfate in a conical flask and a barium chloride in a test tube. Now mix the two solution by tilting the weigh the flask with its contents. So you have to weigh the flask. Now mix the two solution by tilting, swirling the flask. Weigh the flask after the chemical reaction is occurred. Before you have to weigh, after that also you have to weigh. Record your observation. It can be seen that the weight of the flask and the contents remains the same before and after the chemical change. Why this experiment is shown? So that law of conservation of mass of the mass is neither created nor destroyed. How much reactants is what will be the mass of the reactant? The same mass will be of the product formed after the reaction. To understand that, they have they have explained with us this activity. Okay. So in this consider the formation of ammonia in Haber's process from the reaction between. So this also is the same number of reactants and the products are formed, they have mentioned. Now next, the law of constant proportions. Law of constant proportion was proposed by the scientist Joseph Proust in 1779. He states that, what is the law of constant proportion? Says that in a pure chemical compound, The elements are always present in a definite proportion of mass. In a chemical compound, always the compounds are found in a definite proportion. In a definite means in a stable, in a definite manner. The compounds are two or more elements, and notice that each of such compounds has the same elements in same proportion, irrespective of where the compounds came from or who prepared it. For example, water obtained from different sources like rain, well, sea, water and river always consists of the same two elements of hydrogen and water. Whether after rain or after snowfall, whatever it is, the water always it is formed with the H2O. So hydrogen will be 2 and oxygen will be in the same ratio it will be formed. So there will be no change. That is called as law of constant proportion. And hydrogen and oxygen in the ratio 1:8 mass. So the ratio of this mass will be 1:8. The mode of preparation of compounds may be different, but their composition will never change. So that is called as law of constant proportion. Anyhow they will be formed, but the composition will be same. Okay, and this law is also known as the law of definite proportion, also other words we can say, or a law of constant proportion. So here the this chapter gets over. Assignments you have to complete, and even the classworks you have to complete. See to that you complete this. This is the second term portion. Then we'll go for the one more chemistry lesson. Then we'll go for the physics lesson. Okay, thank you students.